Thank you, DevOps India Summit, for awarding Raccoon the award for Best Tools for SRE. I am Sashikant, having close to 25 years of experience across various products and enterprises, and I'm currently heading the ESRE department in DBS Tech India. Mansa, quick intro.
Yeah, Hi all. This is Mansa. So I bring in 12 years of experience in the IT industry. I'm working with DBS Tech for more than 3.5 years now, and I'm currently part of Enterprise SRE transformation team.
From a business problem perspective, which are faced by all enterprises at large, are like systems that we're building are getting more complex and with lots of services connected to one another. And customers being at the heart of everything, whenever there's an outage or an incident, we should ensure that our systems fail gracefully, hence reducing the impact to our customers. For that, we need to first understand the weakness in our system before we can build it better. It is important also that systems are properly tested to ensure reliability and stability. Anything that can go wrong will go wrong, which is Murphy's Law, of course, you know. A single outage can cost millions of dollars lost to the company, and it also impacts the reputation of the company. So Mansa will give you the solution and talk more about chaos engineering and how we do the same at DBS Tech.
Thanks, Shashi, for sharing the business problem. So to address the problem Shashi has just shared, we want to focus on a testing practice which helps to test the system's robustness, and hence we decided to adopt the practice called chaos engineering. So chaos engineering is a practice of performing disruptive experiments in a controlled manner to gain new information around system or application weaknesses, which will help to build more resilient systems. We want chaos testing to be a seamless experience for our users, like application teams or infra teams, whoever wants to practice chaos testing. So we have built an in-house chaos testing tool called Raccoon with the tagline "Wreck your apps and fix the gaps." So Raccoon is a self-service tool, and it helps simulate failures or attacks to detect weaknesses in the applications. So with Raccoon, application teams can combine chaos testing with automated functional testing. It's important for an application to do functional testing during chaos testing so as to understand if the application is behaving as per the steady state during the underlying attacks on the application. Raccoon can be mainly used by three key personas. So the first one being architects. So they can do architecture validations through proactive chaos testing. And the second one being developers. And they can test their code to see how the code reacts to certain failures and continue to fine tune the application to handle those problems. And the third one being testers. So testers can be upskilled to perform chaos testing or to run chaos tests as part of non-functional testing in addition to the functional testing they do. So in this way, we could cover design elements, code elements, and test elements and release a very stable code base to production. So what is the business value we have? The first one being enhanced end user experience. That's the key to anything for our applications. So end user experience defines the brand. Developers can code proper responses or remove add features based on certain application failures or recovery situations. The second one being better dependency management. So it is very vital to identify and understand interdependencies between our applications to better handle cascading failures. Applications can be built with proper handling of transactions across the applications. So the third benefit, early detection. So mean time to detect can be improved by including relevant logging and instrumentation based on failure scenarios. So indicators provided during the insights on problem areas can be proactively embedded within the application. And the next one being faster recovery. So improve the mean time to recover, and failure scenarios can be proactively identified and featured to self-heal, reroute the transactions, graceful degradations. All these can be developed within the application, and the SOPs can be documented accordingly. So what is the overall approach we used, or what are the detailed steps? So we took a 6-step approach in building the in-house chaos testing tool. The first one being we have built a resiliency task force to share the learnings from evaluation. And we have established active cross LOBT task force to drive the initiative forward, which included leadership from various teams such as application teams, infrastructure teams, and security side, etc. And we have built labs for experimentation of various platforms, shared learnings on the insights from various conferences on chaos engineering and observability. And we have commenced attacks in a matured environment, which is the closest to the production, to gain more insights into the behavior of the application while the attacks are happening on the critical components of the application. We have created resiliency guidelines to equip our dev leads, developers with knowledge on how to build resilient and fault-tolerant systems. And what are the key features of Raccoon? So Raccoon has around 60 plus attack vectors supporting various categories such as component failures, stress conditions, internal failures, network conditions, and batch failures and application failures. So across platforms such as VPC, Virtual Private Cloud, PaaS platforms like PCF and OpenShift, and public cloud. And let me give a brief introduction about these attack categories. So what is component failures? So component failures is like how the application behaves when there is loss of application instances, loss of infra services like LDAP or DNS, and loss of dependent or interfacing systems. And the second category is stress conditions. So what is it? So it is about simulation of high resource consumption, like high CPU or high memory or IO, etc., and see how the application behaves. And the third category, the network conditions. So we can perform attacks like network latency, induce some kind of latency between various components of the application, perform attacks like packet loss, packet corruption, etc. And we have internal failures. So applications which are heavily dependent on time zones or certificates can perform attacks such as time drifts, user accounts expiry, certificate expiry, and see how the application behaves. The next one, batch failures. So there are certain cases where applications require offline processing. So wherein they receive and process files from various systems. So these applications can simulate attacks such as, like what if the file comes with 0 bytes, incorrect format, corrupted feeds. So they can simulate such kind of scenarios. And last category, the application failures. So it covers configuration corruption and MQ message corruption. So which would be like MQ messages attacks are useful for messaging systems. So if an application uses MQ as a messaging platform, we could inject attacks like message flood. So what is the second key feature of Raccoon? Raccoon has an iChaos feature, which is called as intelligent chaos. And this automatically understands inbound and outbound interface traffic patterns and creates attacks on its own to simulate the unavailability of the systems. So this reduces human toil and the need to understand the system dependencies before testing. So thus it makes easier to use Raccoon with reduced toil. And the third feature, integration with testing tools. So like I mentioned before, it is recommended that we perform functional tests in conjunction with attack vectors. So we have a feature in Raccoon using which we can integrate testing tools such as JMeter, UFT, and Selenium to run functional tests. And the fourth feature, we have integrated with CI/CD pipelines through custom developed Jenkins plugin, which proactively runs chaos tests with every build and helps to optimize the code. And the last feature, automated report, we have automated reports dashboard, which shows detailed stats on what attacks have been performed. And there are insights such as depth of chaos. This is to drive deeper testing. And lastly, we have Raccoon's observations dashboard, which allows to track applications, expected and actual output during the chaos testing. So I would like to conclude this by saying that Raccoon is now adopted by most of the line of business and applications across the bank, and it is also actively helping in early detection of unknown issues and keeping our systems quite resilient and reliable by shift lefting and avoiding potential incidents which can cause in the production. Thank you.
My lovely audience, we present to you our runners-up of the best tools for DevSecOps award from the tools and technologies category. And that is Xavier IT Architects India Private Limited. Joining us in a few moments is the runners-up team speaking to us about their project. Let's all welcome them.
Hi, everybody. Welcome to DevOps India Summit. Hi, my name is Mandeep. I'm from a company called as ZB IT Architects, based out of India. Okay, we are headquartered in Netherlands, but I work in the Gurgaon office here at Xavier. Okay. we are glad that we have been chosen as a runners-up for the best tools and technology in the DevSecOps area. We feel pride in accepting that award. Thanks, Davos Summit, for that. Okay, a brief introduction about me. I'm Mandeep, working in the area of DevOps and cloud from almost a decade. I come from a background of an application development, and then moved on into the area of DevOps and public cloud computing. So I come from a background of both areas of the application development and then the operationalizing it. So kind of gelled with the way of working of DevOps. So I've been in the area of DevOps since the day, since the time when DevOps was evangelized or DevOps practices started in the industry. Okay. Before telling you in brief about our product, what we did, the journey about it, I would like to quickly introduce Xavia, which is an IT services company. Xavia has been into DevOps and Agile very in early days. In fact, we had our own product under the umbrella of Xavia Labs, which has been #1 in the Gartner Magic Quadrant under the area of application deployment and release orchestration. So Excel deploy and Excel release are those products. Okay. So that's about Xavia. What we do in Xavia is primarily do application consulting, IT services, Agile and DevOps consulting. So we do a lot of DevOps transformation projects. So we go to companies, understand what is their adoption of DevOps practices or Agile practices. We have our own framework to coming up their assessment and creating a product roadmap for that. And what we do typically in those, after that product roadmap is given or assessment is done, do take part in implementing that roadmap, provide our services into that. And this is the area from where the Accelerates was concept was idealized. Because what we typically faced was that whenever we do for any consulting assignment or into a services area, a lot of time the knowledge that we had, the engineers, our architects, our consultants had that knowledge, they have to repeat all that process. So the one problem that we were facing was, as we were scaling up, is how do we scale this quality or how do we scale our resources? So this is the time when this idea of toolifying our knowledge came into picture. So what we did was, okay, looking at the problem which typically we face while implementing DevOps services or doing the transformations of an organization into the DevOps ways of working, we said, okay, rather make it a tool so that our engineers or our implementers can use this tool, apply that knowledge and gain all the benefits which we have gathered so far in doing our all previous experiences. And the typical areas that we operate, or rather accelerates, we thought we operate is first, we started with the platform setup. Now, most of the organizations are on their digital journey. They are modernizing their applications, making them cloud native. Mostly, everybody's trying to move toward microservices architecture because of the obvious benefits you get while adopting microservices. And it marries very well with the concept of containerization. So without a doubt, Kubernetes becomes the de facto standard when you talk about a microservices implementation or digitization or modernization of an application. So this is where we first felt the need of a tool so that we can set up our underlying Kubernetes platform. When I say a Kubernetes platform, it's just not the Kubernetes service. We know it comes in open source flavor, cloud provided, or cloud managed services are there, and then there are enterprise services. But what we understand quickly is that, right after a couple of first two implementations, that it's not just the setup of Kubernetes, it's the whole ecosystem around it. The engineering platform that we need to make a Kubernetes operationalize. So if you look at a typical journey, you set up a Kubernetes, then you set up the security parts of it, authentication, authorization mechanism, distributed tracing, distributed logging, observability stack on top of it. And then comes the CI/CD, how you deploy your applications on top of Kubernetes, managing the Kubernetes, putting a governance aspect on top of it. So it's a complex ecosystem. And as you know, everybody aware of DevOps, you typically work with a lot of different tools to achieve that. So what we thought that, okay, we have implemented these tools in a number of our customers. We have an opinion how best these tools work together. Okay. So every time, rather than doing that engineering effort again and again, we started toolifying it. Okay. The first obvious benefit was got that, okay, our knowledge was into the tool. It knows, okay, if I have to set up a certain platform on a cloud, how a typically landing zone would look like, how my workload accounts would look like, and how my platform would look like. Okay, so everything was baked into the tool, so that and on top of that, it was given a user interface. So that is how we initially started to platformize the setup of cloud, the platforms, so that the workloads can run on top of it. Put that into as a tool, okay, and then have a user interface on top of it so that it takes a shape of what we typically call it as a IDP, which is internal developer platforms. So to give a better developer experience too. Initial audience was again DevOps team, but eventually when we gave a user interface, it could be into a self-service mode, which even a development team can use, even they are not an experience or not an expertise on setting up a cloud platform. So that's the biggest advantage or benefit that we saw immediately the moment we made this tool and rolled out into our second customer, because I won't say first, because first again DevOps team was using, but the second customer, we gave the accessibility of the tool to our development teams. They were able to say, okay, I want to provision a dev environment. I need a Kubernetes. I need logging. I need monitoring. I need distributed tracing. I need centralized logging. All they was doing to just select these options. And the tool was intelligent enough, looking at what cloud provider it is. If it's on AWS, it worked in an AWS way, setting up landing zones, AWS orgs, creating child accounts, setting up the network topology under it, and the environment was then and there. Or if you just want to hook up into an existing landing zone, the tool facilitated that. So all those nitty-gritty tools were able to manage quickly. Be it Azure, for example, okay, now the tool knows, okay, what to do it on Azure. And what typically we were using is we were leveraging a lot of our own, not making our own tools or scripts to do that. We were leveraging what is very much standard available in the industry. For example, provisioning, we have Terraform, okay, or Terragrant that we are using. So we said, okay, we'll leverage those scripts. We'll leverage Terraform modules, wrap it up so that can be orchestrated using our tool. And of course, what are the challenges using Terraform? Because when you scale up, you have multiple modules that needs to work together. So, okay, the tool brings in the capability to plumb each of them, put dependency injection between different modules of Terraform and achieve the same. So I'll touch base a little bit on the architecture, why we chose certain components over another. So architecture-wise, we want it to be scalable, right? And like I said previously, everybody uses a lot of different tools. So what we said, okay, right now Terraform is for example, the tool that everybody uses. Now, what if somebody starts thinking of another tool, maybe use CloudFormation templates or ARM templates for that matter. So tools should be flexible enough to hook up any kind of a technology. So we kind of made an abstraction layer between the way tool does the stuff and the abstraction it provides over the tools that are used to do the work. So there was a kind of a plug and play architecture built up, hook up into it so that these tools can be hooked up. And there's an abstraction in between the way tool wants these dependent tools to work together. So that abstraction was provided. That was one aspect of it. And plus leveraging all the best practices in different areas of continuous integration or continuous deployment or continuous monitoring. For example, like in CI. Now we know CI, there are plethora of tools available. Different organizations use different kind of continuous integration servers. So hence your pipelines change, but the principles of the pipeline still remain the same. So what we focused more on the practices that a pipeline should have, for example, right CI practices. PR workflow should be embedded into it, okay? DevSecOps, leveraging security, moving it onto the left shift, okay? Ensuring that, okay, no vulnerable code is getting even checked it into source code repo, or if it's checked in, it's not getting deployed, the pipelines break. So we kind of enforce those features into our tool itself, okay? So you do not have to worry that, okay, I missed putting up a security check. For example, somebody missed up setting up a tool so that I cannot check in secrets into my Git or to a source code repo. So we kind of enforced all those things into the tool itself. Like I said earlier, we started with platform. So we use Terraform scripts for provisioning stuff, ensure that, okay, we do static code analysis on our Terraform scripts. For example, checking, okay, whether some DevOps engineers has put up a script which is going to open some public ports or sensitive ports onto publicly. So enforcing those governance standards with the pipeline was very much important. So we leverage tools again from CNCF ecosystem like Open Policy Agent. We heavily use OPA, both on infrastructure pipelines, doing scanning of our Terraform scripts. That was on the platform side. And similarly on the application side also, we did the same. We enforced policies in our pipelines so that those governance standards that we want to enforce or those practices that we want to enforce are baked into the pipeline itself and nothing is missed, okay? And again, going by the principle of doing a left shift, the more it's on the left side, the better is the development inner loop, more quick feedback development team gets, and you take the advantage of not of having technical debt or high cost of fixing stuff once it goes into higher environment. So that is how we typically achieved all our the architecture wise. The other few important things I want to show is, apart from policy-based, was the language that we use for the tool. Now we know most of the tools in DevOps area these days are being into Golang. So the obvious choice for our tool was also to use Golang so that we can sometimes customize the tool. For example, I'll give a quick example. Recently, we have been working on a tool called as Telepresence, which improves the developer inner loop experience so that developer or a peer reviewer can run your code rather than just doing a manual walkthrough of the code. So we had to modify the code because since these are open source, we could leverage those, modify their code. And being a Golang gave an advantage that, okay, our engineers know the Golang language and they can modify it based on our needs, hook up into our pipelines. Okay. The other big thing that we thought of was the use of AI/ML, how that can be leveraged. So we applied those principles in the area of cost optimization, predictive scaling of infrastructure. Typically, when you scale an infrastructure, you put some matrices around what's the response time of your APIs or CPU load or the memory usage, okay? And then you say scaling up. So that is more of a traditional way or how typically tools do this today. So what we came up with the idea of, let's do a predictive scaling, and we call it Calibrator. So that does two things. During your performance testing, stress testing, or load testing, it identifies what is the right size of your containers that you need to do. So it analyzes all that data, use regression models, and find out, okay, what are the services, how much you should compute or resources you should allocate to your services, make the decision based on that. And second is on the type of workload, at which hour you predict. Okay, let's say for you have run a platform and over a period of time, let's say 6 to 8 months, you know what is a typical workload, what time of the day workload comes, or you need a high capacity. It might be time of the day, it might be seasonal. So that tools keep a track of your workload and then give you suggestions that, okay, during afternoon, there's a heavy load. So it does the predictive scaling, upfront scales up your workload so that you have enough capacity to deal the workload. Your consumers or end customers does not face a performance challenge. So these are the two big areas that we leverage AI or rather ML to make those decisions while on the tool part of it. Nowadays everybody is sensitive about what is your carbon footprint, how much is your footprint on the outcome of carbon emission. So what's that? We leverage that concept and kind of bake into the tool again that, okay, if you are using certain kind of workload, what is your carbon footprint? And then if your carbon footprint is more than a certain threshold, the tool would give you suggestions, again, in line with right sizing of your resources, leveraging AI and ML regression analysis to find out, okay, what are the right set of resourcing, sizing, predictive, when you need a scaling, make those decisions. So it indirectly affects your carbon footprint also, along with, of course, the FinOps advantage that it gives. Now, this has been the journey so far. What we are working right now in improving accelerates is more of, again, enhancing on the IDPs, making it more robust IDP in the sense that, okay, right now we can provision platform, we can provision pipelines or set up the configurations for our pipelines, how it should work. We are more moving towards on the self-service mode so that the developers, if they need to onboard a new project from a scratch, for example, if a company is using a CI tool XYZ, now pipeline syntax would change for all those tools. So what we are doing is we are giving adapters so that we can adapt to any kind of commonly used CI tools like GitLab, GitHub Actions, or Azure DevOps, or Jenkins, or Circle CI for that matter. So that's one area. Accelerates is working to increase, again, the self-service mode part of it. Platform and application pipelines I've already talked about. And the third area that we are improving or putting up features is around the observability part of it. Now, we can provision stuff. Now, governance, we talked about policies. But what about continuously monitoring it from the perspective of continuous compliance, continuous security monitoring of the platform? We know recent Log4j issue has been there. So we thought of, okay, how a tool can give you continuous compliance. Just example use case. Example for the Log4j vulnerability that was recently discovered. How do you identify what containers are using or what applications are using it? So put as a part of the continuous compliance or continuous security monitoring of the platform or the workload and give a feedback back to the development team on the dashboards. Okay, these are the components which have security loopholes, new vulnerabilities has been detected. So it could be a software composition analysis, checking the complete graph of dependencies that you are using. finding out those and giving you on the dashboard, okay, yeah, these are the components which are getting affected. So building up continuous compliance and continuous security things into the tool itself. So that's what Accelerates has been working on currently. And we hope that we continue to add features and keep on applying to DevOps Institute. And next time, rather another, we come up with a first award rather. That's all I have to share. Thanks a lot for your time. And thanks again for DevOps Institute in recognizing our efforts and awarding us this award to our tool. Thank you very much.